Welcome to today's math lesson on writing inequalities from word problems. Our do now reads, the diagram of a baseball field is composed of a square and a semicircle. As shown here, what is the area of the field in square feet? So my first step is to write out the area formulas for a square as well as for a circle. So the area formula for a square is going to be side squared, or side to the power of 2. And then the area formula for a circle is going to be pi radius square. So the radius of the circle is 90, but that's also the side lengths of the squares. So starting with the circle, I'm going to plug in the radius as 90. I'm going to use 3.14 as pi. So I have 3.14 times 90 squared. According to order of operations, I have to do the exponent first. So 90 squared is 8,100. So then I have to multiply 3.14 times 8,100. And then my answer is going to be 25,434. And then going back to the square, again, the side lengths of the square are 90. So all I'm going to do is do 90 squared, or 90 times 90, which is 8,100. So looking at this semicircle, it's not a full circle and it's not a half circle or a quarter circle. So what I'm going to have to do is figure out how much of a circle is represented in this diagram. And so if I were to break it up, and let's say this part was a full circle right here, I could see that it's 3/4 of a circle. So to find the area of 3/4 of a circle, I'm going to have to multiply 3/4 times the area of a full circle. So that's going to be 3/4 times 25,434. So the area of the figure is going to be the sum of 8,100 plus whatever 3/4 times 25,434 is. When I use a calculator, I get that it's 19,075.5. And once I add together the 8,100 plus 19,075.5, I get 27,175.5. My unit of measurement in this problem is feet, and it's going to be feet squared, since we've found the composite area of this figure. Today's TEK is 8.8a. Our lesson target is I will write one variable inequalities with variables on both sides that represent problems using rational number coefficients and constants. And our DOL is given 4 problems. I will write one variable inequalities with variables on both sides that represent problems using rational number coefficients and constants with 100% accuracy. Some academic vocabulary words that we didn't go over yesterday were the words greater than, and the inequality symbol for the greater than is going to be this symbol right here. Greater than or equal to is going to be that symbol with a line underneath. An inequality has any inequality symbol, so it's either these two symbols right here, or it's going to be the less than symbol, or the less than or equal to symbol. Integer is a positive or negative whole number. Rational numbers include integers, but they also include decimals as well as fractions, so like a over b, and then like 0.12 repeating. Remember that a variable is a letter that represents a number, and it can be any letter from A through Z, but we usually use X to represent an unknown in math. And so if we look at this, this picture shows the difference between equations, inequalities, and a function. For this first problem, it says, let's examine how to write inequality based on a situation that involves one variable. A yellow hot air balloon is 100 feet above the ground and rising at a rate of 8 feet per second. So my keywords are 100 feet off the ground, rising, which means that I'm going to be adding at a rate of 8 feet per. Per tells me that whatever variable we use, 8 is probably going to be our coefficient or the number in front, or also known as a slope. An orange hot air balloon is 160 feet off the ground and rising at a rate of 5 feet per second. We have to write an inequality to find out how long will the yellow balloon be higher than the orange balloon. So what we did yesterday was we wrote equations, and so we just set two equations equal to each other. Today, we're going to have to write two inequalities, or two, I guess, parts of an equation, and then we're going to have to figure out what is the inequality symbol that best represents the situation that the problem wants us to represent. So step one, we're going to continue from yesterday. We're going to write an expression representing the height of the yellow balloon. That's the balloon that came first. So 100 feet off the ground, that's our initial value. And so that's going to be our constant. We have 100. We figured out that rising means that we're going to add something to it, the value that it's rising, the rate, which is 8 feet per second. So if X represents the number of seconds, I'll write that as well, number of seconds passed. Then we have to write the equation for the height of the orange balloon. So the orange balloon starts off 160 feet above the ground, and it rises, so again we're adding, at a rate of 5 feet per second, so it's going to be 5x this time. And the equation that we have to write is we have to write an inequality to find out how long will the yellow balloon, so this first equation, be higher than the orange balloon. Be higher is another way to say greater than. So we know that we're going to use the greater than symbol. So we have our equations, 100 plus 8x is greater than 160 plus 5x. The thing about inequalities is that if we flip the order of the equations, then we also have to flip the inequality symbol. So this is equivalent, or the same thing, to 160 plus 5x is less than 100 plus 8x. This I do problem reads, two water tanks hold 28.62 gallons and 31.2 gallons of water. The larger tank is leaking, so the keyword is leaking. which means that we're going to be subtracting at a rate of 0.12 gallons per hour. So if we're using X to represent the number of hours, then 0.12 is going to be the coefficient or our slope. The smaller tank is leaking at a rate of 0.08 gallons per hour. Write an inequality that represents how many hours there will be less water in the larger tank than in the smaller tank. So if I wanted to use H, I could also use H to represent the number of hours. So I'm going to first start off writing an expression representing the amount in the larger tank. So the larger tank started off with 31.2 gallons of water. So that is our constant, and because it's our starting value, and because it's leaking, we're going to be subtracting the 0.12 x or h, whichever variable that you want to use. Then for the smaller tank, starts off with 28.62 gallons of water, and it's leaking, so we're subtracting 0.08 x or h, whichever variable. Then if we look back at the problem, it says we have to write an inequality that represents how many hours there will be less water in the larger tank than in the smaller tank. So the easiest thing to do is if it says less water, then we're going to be using the less than symbol. So we have the amount in the larger tank, which is 31.2 minus 0.12x is less than 28.62 minus 0.08x. Again, if we want to switch the order of the equations, if I have the 28.62 first, minus 0.08x, then I have to also flip the inequality symbol so that it's saying that the amount in the smaller tank is greater than the amount in the larger tank, which is also the same thing as when there'll be less water in the larger tank. There's some we do problems and then some you do problems. And finally, your 4-question DOL on Google Forms. Thank you so much for following along in today's math lesson, and see you in the next math video.